Okay, Trig, this is section 12.2. It's like part B of 12.2. We started talking about like solving systems of equations, so like solving for x, y, and z using matrices and augmenting matrices. We did like the reduced row echelon form a little bit yesterday, and that's kind of messy. And we're going to do a couple of those today again. So I'm going to switch some things up. We're going to skip a couple of examples, like we're not going to do example 5, 6, or 7, I don't think. No, we're going to skip those guys. And then I'm going to change some examples on example 4. So we are going to do part A, but then part B we're going to cross off, and I'm going to change him to just be a 2 by 2 matrix, or a x and y solving for a matrix. And then I'm going to change your homework assignment up just ever so slightly. So just be prepared for that. Here we go. Let's answer example 3 first. This one is just asking for some information, like if this is the answer, what does that mean? So it says the matrices below are in reduced row echelon form. So this is the final answer, like what we get. It says write the system represented by each matrix and then find the solutions, if any, and classify it as, I don't like when it says consistent with infinitely many solutions, or inconsistent. Just tell me whether it has one solution, which is what consistent means, whether it has infinitely many solutions, or whether it has no solution. So just tell me one of those 3 things, and I think there's one of each on here, so we'll see that here in a second. All right, so I don't care about the consistent, inconsistent, whatever. I don't really care about that. Just give me how many solutions there are. Okay, the first thing it wants us to do, though, is write out what this means right here. So if that's the answer, this means that 1x minus 3y equals 4, okay? But then this bottom one says that 0x plus 0y equals 0, okay? And the deal here is that if I'm looking at just this bottom one in general, we've had before on systems of equations where we have like 0 equals 0, which is what this is saying, 0x plus 0y, that's the same thing as 0. When 0 equals 0, 0 equals 0 all the time. So this is going to lead to infinitely many solutions. And the way that we can look at that, infinite solutions, is that it wouldn't matter what x was and it wouldn't matter what y was, as long as, because you're taking it times 0, and the 0 is going to knock out whatever the x and y value are anyway, so it's not going to really matter, and I can plug in whatever I want to in for x and y. Doesn't really matter that this equation up here is a thing. The fact that we have 0 equals 0 somewhere in our function leads us to infinitely many solutions, okay? B, this top row says x, 1x, plus 0y plus 0z equals 3. So x equals 3. This one says 0x plus 1y plus 0z equals negative 7. And this one says 0x, 0y, but 1z equals 4, okay? So if that's the case, then I have 3, negative 7, 4. That is what he's equal to, and he has one solution, right? It's like, that's what it is. Is 3, negative 7, 4. That's the one solution that works, okay? So, and you kind of notice that by like the diagonal 1 pattern. That is going to just lead you to one solution, okay? C, when we have this going on here, this says 1x plus 2y equals negative 1, which is that top row. But then the bottom row says 0x plus 0y equals 3, which, if I look at this bottom row, 0x plus 0y is just going to be 0, right? Like if no matter what x and y are, that's not going to work. And 0 equals 3 never happens. I shouldn't put x there. This is not going to happen. So I have no solutions in this case that are going to work, because I end up with that 0 equals 3. Or I end up with something that doesn't make sense, like 2 numbers that are not equal to each other being equal, and that doesn't happen. So that's going to lead me to no solutions. So that's kind of what they're asking for on the ABC part. You have a couple questions like that, or similar to that, on your homework assignment, where they're just asking you to like tell me what this means, or decipher the answer if this is the solution, type of thing. So we're going to do some reduced row echelon examples again. We're going to do 2 of them. The first one starts and looks like this. So rather than doing like substitution and elimination, we're doing it in reduced echelon form, which is exactly what substitution and elimination are, mainly elimination. It's just getting rid of all the variables. So if I write this thing as an augmented matrix, I can hear you cursing me right now because I know that you don't like this process at all. My kids last year just loved it a whole lot. So yeah, even though I'm recording this ahead of time, I know that you're really hating this process, okay? But you know, whatever, it'll be fine. We'll make it through. So this part, that's what my augmented matrix is going to look like. And the first thing that I want to try to do, I don't know if I gave you steps yesterday. I think I did. Yep, step number 1 is get 1 in the top left corner. Okay, we kind of work in like a circle pattern. So we try to work with this one, and then this one, and then get this one, and then get this one. Okay, so that's kind of the pattern that we go with. So if I'm trying to get this one to be a 1, I am going to take, and I am going to put, I don't remember how I wrote this out. I'm going to take half of row 1, like I'm going to multiply through by half, and I'm going to put that back into row 1. So row 1 is equal to half of row 1. I'm not going to touch row 2 yet. Row 2 is going to stay -4, 1, 18. I'm not going to touch him at all, but I'm going to take half of this number and just put it back in that spot. So half of 2 is 1, half of 1 is 1/2, which is gross, and half of 0 is 0. So I'm taking half of it, putting it back in that same spot. Okay, now I have the first thing checked off. I have 1 in that spot, and he's good to go. Okay, now I want to try to get 0 in this spot. Okay, that's very next step. Okay, and so to do that, I have to adjust the row 2. Okay, so like this row has to change, but what I'm going to do is like with elimination, I would multiply this by +4 in order for these two to cancel, right? Like that's what I would do. So I'm going to take 4 times row 1, and let me go out here, 4 times row 1, and add that to row 2, and I'm going to put that back in row 2. Okay, so a little bit confusing. If I take 4 times this guy, right, this guy will become 4, this guy will become 2, this guy will stay as 0, right? 4, 2, 0, if I take him times 4, all the way across, right, like that. Okay, if I add these guys to these guys, this 4 and -4 will become 0, 2 and 1 will become 3, and 0 and 18 will stay 18, like that. Okay, row 1 I'm not touching yet. Like I used him, but I'm not replacing row 1 with anything. He gets to stay the same, but row 2 gets switched. Okay, so now my second box is checked. I've got 0 in this spot, so that's good to go. Now the next thing that I want to do is work on this 3. Okay, so I have to get this 3 to change to a 1, and the only thing I can do is divide by 3. So I'm going to take R2, and I'm going to divide it by 3, or you can take 1/3 of it, and I'm going to put that back in that row 2. Okay, so row 1's not going to even be touched. He's not going to be dealt with at all. I'm going to do that, and then I'm going to take 1/3 of each one of these. So 0 divided by 3 is 0, 3 divided by 3 is 1, 18 divided by 3 is 6. So I have that going on. Oh, we're getting close. We're getting close. We have one more box left to do, and it is to try to get this to be 0. Okay. All right, my bottom row is done. Like I don't need to do anything with that bottom row, so I'm just going to rewrite it as 0, 1, 6. He's good to go. Okay, but in order to get this to be a 0, I would have to take this row times a -1/2, just like you would do in elimination, right? If I multiply through by a -1/2, and then I add that back to this guy, he will end up crossing that 1 out, right? So like -1/2 times 0 is 0, -1/2 times 1 is -1/2, and then -1/2 times 6 is -3. Okay, I'm going to take this row, and I'm going to add it to this one, right? And so 0 and 1 becomes 1. 1/2 and -1/2 is 0, and 0 and -3 is -3, and that's what he will look like. Okay, so I was replacing row 1 with, here's the tricky part, I took -1/2 times row 2, and I added it back to row 1. Okay, and then I put that back in row 1. So this notation can be kind of bothersome sometimes. If you don't get that notation quite right, that's fine. But it's just like doing the process of elimination without writing out the X's and Y's and stuff. So some guy came up with this and thought, oh my gosh, that's brilliant. Well, I don't know if I necessarily care for it. I'd rather probably just do substitution elimination, but the idea behind it, I get it. Like, this can lead to other things that's important. So in this process, this deciphers as the x equals -3, which is that top row, and y equals 6. So -3 comma 6 is the solution where those two equations are going to cross each other. Okay. All right. So next I have b. We're going to cross out b. I don't want you to do a 3 by 3. A 3 by 3 is terribly, terribly confusing. So what I'm going to do is I'm going to have you do this one instead. Okay, so write that down, put him over here. We have all of this room to work because we're not doing any of these examples. So just add him in. This is the new example B, write him in, and we'll solve him here in a second. Then I'm going to show you what to change on your homework assignment here in a second. So if I augment this matrix, he will look like, wait a second, 1, 3, -1. And I have 2, -1, 5 is what I will have there. Okay, now, really wonderful thing is that I already have a 1 in this spot. Okay, so now we're going to work with this guy and we're going to make him become a 2. Okay, so just like in normal elimination, I'm going to multiply this guy by -2, right? And then these two things will end up canceling to make that 0. Okay, that's what I want to do. So if I multiply that through, this will be -2, this will be -6, this will be +2, okay? So I'm going to rewrite him, okay? My top row is going to stay 1, 3, -1, okay? But my bottom row is going to be whatever I take when I add this to this, okay? So -2 and 2 is 0, -6 and 1 is -7, and then 2 and 5 is +7. Okay, so I've got that going on, all right? Okay. What I did was I replaced row 2, so I put everything back into row 2, and I took -2 times row 1 and added it to row 2. Okay, so if you're working on that notation, trying to get that nailed down, that's what he looks like. I replaced the row 2 with the new stuff, okay? And that's what he looks like, all right? Now we go from here, and the next thing we try to do is we try to get this guy to be a +1, okay? So what I'm going to have to do is I'm going to have to divide by -7, okay? Now typically we use multiply, so instead of like dividing by -7, I would be multiplying by 1/7, but we'll just go ahead and we'll just write it. We'll just take R2 divided by -7. We'll just do that. I don't really care how you write it. So we don't have to do the 1/7 thing. We can just divide by -7. And I'm going to put that back into row 2. So row 1 is not going to be touched. He's going to stay 1, 3, -1. He gets to chill. But now I'm going to take row 2 and divide by -7. So 0 divided by -7 is 0. -7 divided by -7 is 1. And 7 divided by -7 is -1. Okay? And now we are very, very, very close. We just need to get this guy to be a 0. So to get him to be a 0, I'm going to multiply this bottom one by -3. -3 times 0 is 0. -3 times 1 is -3. That will get these to cancel. And then -3 times -1 is +3. Okay, so here's my matrix. Okay, 0, 1, -1. He's good to go. He's ready to go. I'm going to replace row 1 with, I took -3 times row 2. -3 times row 2, and I'm adding that to row 1, and I'm putting it back in row 1. So when I add those together, 1 and 0 becomes 1, -3 and -3 becomes 0, and what was it, 1 and 3, -1 and 3 becomes 2. So that is what my matrix looks like when I'm done, and I know I'm done because I have the 1, 0, 0, 1 thing, and this says 1x equals 2 and 1y equals -1. So I have 2 comma -1. That is the solution for this guy. Okay, so that was really kind of fast, but that's just more reduced row echelon. Basically, it's just elimination without the x's and y's, and then you put them back in at the end. So the more you, like, I'm used to doing this. I've done this. I had to do 3 by 3s like crazy when I was in college. When I was getting my master's degree, we did a bunch of 3 by 3s to solve, but we had to do like story problems, so we actually were solving for something as well, which was another element in there. And the more you do it, the easier it gets, I promise you. You know, it is kind of a struggle to learn the notation and all that stuff, so I get it. It's icky. So you should be able to do, or have maybe done, the front side And this is just asking you for information. Like, what does this mean? Or how would you write this as a matrix or whatever? The backside is the only thing that you will have to solve for. So like on number 7, you have x's and y's that you're solving for, but you have 3 equations, which is kind of odd. If you augment that, you end up with something that looks like this, okay? And then what I'm going to have you do is I'm going to say number 7 is going to be bonus. You attempt it because some of you guys might be able to do this, or all of you, I don't know. But the fact that you only have 2 variables, you're going to end up with, or hopefully end up with, at the final, you're going to end up with 1, 0, 0, 1 here, and then you'll have numbers over on this side, and those will be your solutions. But your bottom row is just going to cancel out to zeros, okay? So try number 7. See if you can get all the way through that with the 0 being your bottom row, just because it's like only x and y, so you really only need these top 2, but your bottom row has to go somewhere. So he's going to cancel out to be zeros. And then number 8, rather than doing a 3 by 3, replace it with this function. I'll just have you do a 2 by 2 that you're solving for using that reduced row echelon, okay? So really, this one's bonus, but attempt this one and see how far you get on that. And that's changing that last problem. So don't do number 8. If you want to try to do number 8, you can for bonus as well. That one's like really tough. It's a lot of steps because it's a 3 by 3, but you can try it if you want to. But otherwise change number 8 to that. Okay,